Thank you very much for coming to my presentation. I'm really excited to present this today. Like I said, I've had this presentation sitting around for about a year when I originally crafted it. So I'm very excited to finally to present it to you today. First, I'll do some introductions, if it'll let me. My name is Josh. I'm a senior web architect at Pegasystems. I'm also the tech lead on the Pega Academy project. It's the main site that we use people to go and they can get their training on how to use Pega software. I've been with Pega for about 3 years, but I've been writing PHP for about 12 years now. It's been a minute at this point. I've been writing PHP even longer than that, going all the way back to 1999. I've been writing code. So yes, I'm actually older than I was. And so when I came to Pega, one of the initiatives that I started was to really do a deep dive into automated testing and to learn it and to start to implement it on our projects. And kind of going along that journey, I did a lot of reading. I started practicing test-driven development and just doing regular, conventional development. I'll talk about that in a second. And also mentoring other developers along the way. And so as I was going on this journey to really learn it and master it and incorporate it in my day-to-day work. This presentation is kind of a distillation of a lot of the major either ideas or concepts that I learned along the way, because I found that more than just being able to write your first test and to run it, there's actually a lot more going on. There's kind of a philosophy and approach to writing your tests to make it effective, to make it long-term and sustainable. So that's one of the things you really want to avoid. You don't want to write a test and then, oh look, I make a change and my test breaks and you have to go fix the test, because the test is going to become a liability and you're ultimately just going to have to abandon it, right? Or you have to redo it. And so that was my ultimate objective of this. I want to write the test once. I don't want it to break. I don't want it to continue. And so that's what I'm going to talk about here today. You're going to notice I'm actually not going to run any tests, and I'm not going to show any code, which is not really usual for an automated testing presentation. So like I said, I'm going to be presenting ideas and concepts, a way of thinking about your tests, and to structure them in a way that will be effective for you as developers. All right. So, first thing I want to talk about is the nature of software development as a practice. It's a craft, like any other craft, like you're doing painting or you're doing sculpture, stuff like that. And like those crafts, it's messy business. As we're going along writing our code, we're trying to solve the problem. It's going to be messy, and you're going to have to go back and clean it up afterwards and stuff. It's just part of the nature of the craft of writing software. The problem with software development, though, and the fact that it is messy, is that we have to live with that mess. It's not like you're a painter and you're working on your beautiful canvas and you put your paints and it's all pristine and you present it and like, look, isn't this beautiful, what I created. They don't see the back of your studio in back, right, where it's completely covered in paint and you're not going to go in there and eat, for example. Unfortunately, we don't have that privilege as software developers. We have to live with that mess, and we have to accommodate for it. All of us have dealt with this before, software entropy, technical debt, workarounds, all those kinds of, we have lots of different words for it, but at the end of the day, it's just a big mess of software that we have to deal with. The problem with that mess, too, with software, and this is why it's so detrimental to a project, because messy code causes errors. And because software is so interconnected, those errors actually manifest in a power distribution. And so basically what that means is like you have like an avalanche, for example. You have a snowflake, there's another snowflake that turns into a snowball, and then turns into this big thing that goes down the mountain, right? It hits a critical state. That is the exact same kind of effect that goes on software. It hits a power distribution, and it reaches a critical state, and then your software is no longer maintainable. What usually happens then? Oh, you get excited, I'm going to abandon the whole project, I'm going to start over, and it's going to be perfect again this time, right? And that's why you have all those errors in your software, it's because of that power law distribution. Okay, so tests can help with that. And how does it help? Because tests are going to be part of of your feedback loop. You want to run your tests earlier and faster in order so that your bugs don't stay in the code and add to the pile of the mess. You want to catch it first. And that's how tests can help with that. But where do you start? Where do you write your first test? When I'm looking at my code, I actually I don't look for code like what I want to add test coverage for. I look at code, what should I not add tests for? They really break down to three things. One, don't write tests for code that's not yours. This could be like your like a Drupal contrib module, Drupal core, code that's in a vendor directory. Now, I know that might sound, oh, obvious, I'm not supposed to test that. But, let's say you have your own function and using entity type manager. You're still mostly testing Drupal core there. That's also a trivial test, which I'll talk about second. Don't add test coverage for basic or trivial code. What do I mean by that? That's like your getters and your setters, stuff that doesn't really have a lot of logic in it. It's really straightforward. This one might be a little bit controversial, especially for some projects really want to get that 100% test coverage, like as a really nice metric that you can show to management and stuff. And I'm going to argue that that's a waste of time and resources to get there. Because, frankly, you're not offering any value. It's just not really worth adding a test for.
Or another example that came up recently was constructors that are just doing dependency injection.
Mm-hmm. Exactly.
Can you repeat it for the recording?
Oh, yeah. So Benjamin mentioned a great example is doing tests for like constructors. They're not worth adding in because Drupal already has tests for them. It already has it covered, so don't bother. The third one is overcomplicated code. Some of you might be going, what are you talking about? So this is actually a little bit of a trick. By overcomplicated code, I mean something very specific. This is code like a really big function that has lots of conditions in it, or code that has a lot of dependencies in it, like maybe 15 dependencies. That code is way overcomplicated. You should not add a test for that. Instead, you should refactor, simplify the code, and then add your test coverage for that. Now, there's some flexibility here. If you want to add a test to get to that refactoring stage, okay, but that's probably not going to be the final state of that test, because you're going to write another one for that final refactored code that's been cleaned up. And so, we'll come back to that. Okay, so you found some code that's not too complicated, you found some code that's not too simple, and you found code that you wrote. All right, here's a good candidate for the kinds of code that I want to write tests for. Now, I'm going to be talking in the context of Drupal tests. I mean, there's other kinds of tests. There's like end-to-end tests with vhat, for example. I'm actually not going to be talking about that, though that's perfectly legitimate, and you should be running vhat tests as well. This one is going to be Drupal's functional tests, kernel tests, and unit tests. Who here has written tests like that before? Okay, cool. So if you've installed Drupal, these come out of the box for you. You can start writing these tests right away. You don't really have to install any extra infrastructure. You just have to configure PHP, and then you can run those tests. So that's what I'm talking about today specifically. So like I said, Drupal has 3 different test types. We have the kernel, unit, and functional tests. So that's all great, but when do you use these? Now I consider 3 factors when I'm going to decide what kind of test I'm going to write. First is my priority. Do I want really fast tests, or do I want tests that are going to catch more like a lot of bugs? Second, what do my dependencies look like? Because that's also going to influence. And I'll talk about dependencies more in a second. That's going to influence the kind of test you write. And finally, the design of your code, the decisions that you've made in terms of your code responsibility, that's also going to influence the kind of test that you write. All right, let's talk about priority. And I'm actually going to be borrowing this great idea from this book that I read called Unit Testing Principles, Practices, and Patterns. This is a fantastic book. This is kind of what got me started on this whole journey of learning about automated tests. And I thought he did a great job, so I'm going to just kind of present his ideas here. This is by Vladimir Korokov. So you have 4 pillars to a great automated test. 1, resistance to refactoring. Make sure that like when you clean up your code, it doesn't break your test. That's a sustainable test, right? Second one is protection from regressions. Make sure that your test can actually catch the bugs as they come up. If it's not catching the bugs, it's not a valuable test. Third, fast feedback. You don't want to be spending hours running your tests, right? That's going to create a bottleneck. So you need to make sure your tests are fast. And then finally, maintainability. You want to make sure that your tests are easy to maintain, the code is clean, but you also make sure it's easy to run. For example, you don't want to have to depend on Apache Solr with your Drupal instance in order to run some of your search tests, for example. Because you'll say you pass it off to another developer who doesn't have Solr. Well, none of the tests are going to run. So you want to make sure it's easy. 3 of these in particular really interact with each other. We have to kind of create a compromise. I'm not going to go through every little point here, but the main point to take away is that an ideal test would be fast, it would catch all the bugs, and it would never break whenever you do a code change.
Yes, please.
Unfortunately, that's not possible. That is an unachievable ideal. So we're going to have to make some compromises along the way. But there's one factor, one pillar that you simply can't compromise on, and that's your ability to let your code change. Because new requirements come in, you get new insights along the way. You want to make sure you can change your code to accommodate that. But if you change your code and your tests break, again, it defeats the purpose of changing the code, right? It's not sustainable. So this becomes kind of your true north. No matter what I do, I need to make sure my tests aren't going to break. That's a working line. So now you have to kind of play a balancing act. Okay, what's important to me now, besides making sure my code is stable and doesn't change? Do I want to catch as many bugs as possible with my test? Or do I want to have my test really, really fast? And so you kind of have to make a decision between the two. With functional tests, the thing is, it's going to be a lot slower. And like I said, right, one of the pillars of a good test is fast tests. So if you're writing all functional tests, you're going to catch a lot of bugs, but they're going to be really slow. And so, and again, when I mention this too, when I say slow, this is you as a developer. This isn't necessarily in pipelines. This is you literally writing your code, running your test, writing your code, running your test. That's the kind of workflow that I'm talking about right now. But if you have to wait 20 minutes to run all your tests, you're not going to do it, right? It's a real bottleneck. Likewise, though, if you have really fast tests, you're simply just not going to catch as many bugs. And I'll give you some more insight into why that happens as well. So there really is a balancing. And kernel tests kind of live in between there. Okay, let's talk a little bit about dependencies and how are these going to influence the kind of tests that you write. Speaking really broadly and really simply, I kind of like to think of dependencies in two categories. You have your internal dependencies and your external. Internal are just really simple. This class depends on this class. It's literally just code talking to each other. You're not interacting with any databases or anything like that. But then external dependencies are, like I said, that's where you interact with databases and other kind of third-party services. And Drupal interacts, or the different test types, unit, kernel, and functional tests, interact with dependencies differently. Unit tests, you do a lot of mocking. Who's familiar with mocking? Okay, so for those who might not be familiar, you're essentially kind of spoofing the inputs and outputs of your classes, and you have to basically build all your dependencies right in your code. Nothing is bootstrapped for you for free, so you have to do a lot of that kind of wire work yourself in order to get your tests to run. This is fine if you just have one or two dependencies in there, but as soon as you get more than that, you're going to have a wall of code that's not fun to maintain, and you're going to dread looking at that code. And so that's generally what mocking is. And it's pretty much the domain of unit tests. You're not really going to do it with kernel tests so much, though you certainly can. With kernel tests, you can see here, you can do unit tests. You can do mocking, but you also can bootstrap Drupal. And kernel tests are actually the closest to writing actual Drupal code, because you're using the Drupal API as your writing your test. And then finally, you have your functional tests. This also bootstraps Drupal, so you can use the database just like in kernel tests. But I like the frame for this presentation, the browser is also a dependency of functional tests. And so because with functional tests, you're actually writing an API that interacts with the browser. Like you're clicking buttons and entering forms and stuff like that. So it's really like a user using your project. I'll touch on real briefly between BHAT and some of the other behavioral tests. The way I like to think about those tests is they are kind of functional where you're interacting with the browser. But in those cases, more often, you might be running your behavioral tests on an actual copy of this site, as opposed to a functional where you are installing a site from scratch every single time you're running the test. And you're only installing the modules at that moment that you want to test. So it's not all the dependencies of your project, it's only the ones that are concerned with that particular piece of functionality that you're testing. Whereas like BHAT or end-to-end tests are running on the site entirely. So usually you're going to use them in conjunction with each other. But again, that usually happens like with some kind of build. Whereas what I'm talking about today is like this is you as a developer writing your test, and then before you even push up your code. That's what this presentation shows. In a typical software project, like I said, typical, not Drupal, you tend to have a distribution of tests look like this. You have a gigantic base of unit tests at the bottom, a mid-level collection of kernel in the middle, and then a bunch of functional tests at the top. We're kind of testing the same, like the happy path of your application. The most expected behavior to happen on your site, you'll cover with functional tests, and then you're going to test your corner cases, your edge cases with your kernel unit tests. And also, as you go up the pyramid, the functional test has like all the dependencies, and unit tests just have a couple in the kernel. Yeah, I talked about that. Drupal looks more like this. And anyone, well, before I get to that, Drupal has a ton of functional tests. About half the tests that when I scanned the project were about functional. And then about a third were kernel, and then we had like not even 20% were unit tests. Why do you think that is?
The history of the project, we started off in Drupal 7 with functional tests, and we started converting those to PHP unit.
Oh, okay. So yeah, the history of the project too. But in my investigation too, do you think it also because it uses a database so much, and unit tests are just not really great with testing against a database? So that was one thing that I observed, is that because kernel and functional tests, they're much better. They can bootstrap Drupal. You can interact with the database. So they're just a lot easier to write tests with kernel and functional, and so you can get a lot more of that. Because Drupal really is a database-driven website in terms of its structure and stuff. You create your content types and your fields. Where in another platform, you might not do that in a database. You're going to be writing classes. Like if you're just doing a Symfony project, for example. It doesn't depend on the database as much. Yeah, these are just some of the numbers. Okay, so let's talk a little bit about design. This also can influence the kind of tests you write, depending on what your code is doing. Again, drastically oversimplifying code architecture, I like to think of code in kind of two camps or two categories. One is you have your infrastructure code, and then second you have your domain code. Who here is familiar with domain-driven design? So, domain-driven design is the idea that you write code that represents concepts in your business. And actually, I have an example. I'll talk about them one second. Okay, infrastructure code. So this is concerned with the needs of software. This is the code that handles like your caching layer, your route handlers, authentication, sessions, all that stuff. Anything like that you see kind of shared across different applications. That's your infrastructure code, generally speaking. You can have some kind of this is where software just acts as software, but it doesn't really satisfy any business needs. That's where domain code comes in from domain-driven design. This is where you're representing business concepts in your application. So for example, let's say I run a bookstore. And what kind of concepts exist in a bookstore? Well, you have inventory, you have payroll, you have employees, you have hours. All of these exist outside the application, but you can represent them in your application as well by creating some kind of management application for the bookstore owners, for example. I think one of the words Robert Martin said in Clean Architecture is when you write your code, you should be writing screaming architecture. And what he means by that is when you look at an application, oh, I know exactly what this is for. That's because it has things like, here's a book content type, or here is a view with a roster of my inventory, right? Oh, this is a website just for, this is a bookstore website. This is my domain. So, quick question. Where does Drupal like to put its domain concepts?
I was going to say in the database or configuration.
Exactly, in configuration. That's why you get things like content types, and you get fields. A Drupal distribution, what is that? That's just a Drupal representation of some kind of domain problem. So you have a Drupal distribution, for those who don't know, is you might have one for a learning platform, or for it's been a while since I've worked on one. Can someone name a Drupal distribution off the cuff?
Thunder.
What's that?
Thunder. For publishing.
Yeah, that's kind of a general Drupal development.
For publishing.
For publishing, there you go. So that's basically what the Drupal distribution does. It's a pre-configured set of features for satisfying the needs of a particular domain. So why do we need tests for both? Well, it should be pretty apparent, right? So first of all, you need tests for infrastructure code to make sure that page is actually loading, that our users can log in, right? That they're not seeing somebody else's cached data on their page. Has that ever happened to anyone here? Yeah, right? So you got to make sure your application is working like it should. Why do we need tests for domain code? You got to make sure they can buy the book, right? You got to make sure that they're actually satisfying the business requirements. Otherwise, you just have this really expensive brochure right, on your site. So, yeah. Also, quick question. So as you're looking at the code and you're trying to decide, all right, what code is worth adding a test? Which one do you think that offers more value?
Domain.
Domain, right? Yeah, because you're satisfying the business requirements. Nobody's really going to care that much if some people get logged out after half an hour. But if they can't buy a book, the business person really doesn't care. I mean, definitely you got to fix that. People shouldn't be logging out. That's a security issue, right? But yeah, make sure that people can buy it. Oh yeah, actually one thing too I wanted to stress about that between infrastructure and domain is that in your application, infrastructure code usually takes up the vast amount of code in your application, where domain code is a much smaller portion. Just to kind of give an example, I was working on an application called Access Policy, which allowed us to essentially section off different parts of the site for different member types. Pretty straightforward use case, like certain clients or certain professionals shouldn't be able to see certain content. The actual code to satisfy that particular business requirement, like this professional can't see this node, is 2% of the code for that module. The rest of it was infrastructure code. And so you can imagine writing a test just for that one, pretty quick. Infrastructure, not so much. Okay. So here's kind of a way to think about how you're going to distribute tests, because your kernel and unit tests and function tests don't actually live in isolation. They're going to have a kind of harmonious relationship with each other as you think about your testing strategy. This is way oversimplified. This is just your basic layer architecture where you have some code that has dependencies that don't know about each other. All of us have worked with this, even if we haven't familiar with the technical name of the architecture. So in this example here, maybe I have some kind of book listing code. I'm not really sure what it is exactly. It doesn't really matter for this presentation. But you have some code that is concerned with book listing. This is your domain code. And so I'm going to add some kernel or unit tests for that. And again, this is the smallest piece of code. And this code is going to run really fast. In my kernel and unit, I can capture all sorts of edge cases and corner cases. But like I said earlier, you can have really fast tests, but it's not going to catch everything. And this is why. As you can see, if I don't have any other tests, my render service and my view controller won't be covered. It's not going to know anything about my book listing. So those are opportunities for more bugs to happen. That's part of my application. So one thing I can do, I can certainly add some unit tests and some kernel tests for my view controller. But if I'm limited on time, or if I'm fairly certain this is pretty stable code, again, going back to trivial code, you have to kind of weigh the possibility of bugs happening. You can say, you know what, I'm probably fine with just adding some functional tests for my controller and my render service. And so I'll have some coverage for that there, and for the happy path, and then I'm going to have a lot of coverage for all the edge case and corner cases for my book listing, my domain code. So this is at a high level. There's lots of different strategies you can do, but this is a really good kind of place to start. Think about how to write your tests and distribute your tests. Question?
In this slide here, this example, Josh, is it that the unit kernel test is making sure that you can produce a list of books, where the functional test is making sure the users can see that list of books for clicking one to buy?
I didn't think that far. I was thinking in terms of this is my domain code, this is my infrastructure code. So this really can be anything you want. Let's say you have a class of book listing which is responsible for pulling books from the database. And maybe there's some constraints in there, like I only want to show books filtered by this genre, for example. And so you might add a bunch of unit or kernel tests where you pass in those filters for the books, and then you can go through all that and just make sure your listing is working. Now the actual rendering part, right now this is just the data level. At the rendering part, actually showing it on the page, That you might capture with a functional test. So that renders. So think of it another way, like maybe you're only really dealing with data and manipulation of data with your kernel unit test, and you can quickly go through all sorts of different scenarios. Meanwhile, with a functional test, you can just kind of test happy path. Like this is how most people are going to interact.
Well, this is certainly not always the case, but within Drupal, the view controller and the render service would be part of code you didn't write.
Exactly. That's exactly right, yeah. I mean, for illustrative purposes.
Yeah.
Yeah. But you're actually right. If I was doing an MR review and I saw someone doing this, I'm like, nope, don't do that. So, but a great point, thank you. Okay, so automated tests in practice. Again, I'm not going to be running any code or anything, so we're just going to have a brief discussion. Broadly speaking, there are kind of two ways you can write your tests. You can write your tests after you do your feature development. It's perfectly acceptable. In fact, you're probably going to do that. When you leave this room and you start writing your first test, you want to test your current code. But then there's the other one too, test-driven development, where you write your tests before you write your future code. There are a lot of advocates for test-driven development, but honestly, especially in the Drupal world, you're going to be doing a combination of both as you get comfortable in testing. Who here is familiar with test-driven development and kind of know the process? Okay. Yeah, so just to kind of describe the process of test-driven development is that you're going to write your test. There doesn't have to be any production code in there. I've actually had some developers in my company who's like, well, if I don't have any code to test, like, what can I test? It's like, that's fine. Your test is going to fail. That's what you want it to do, right? Especially with a functional test, you really don't need any code at all because you're testing through a browser. So first you do is you write your test to fail. You're basically establishing, like, this is what I expect my code to do. And then from there, this is the fun part. This is my favorite part. Here you can start writing some of the worst code you've ever written in your life. You can do all the worst practices you want to do. You can put in, don't do dependency injection, hard code all your strings and your integers and all that stuff. Just have fun, because right now you're solving the problem. You're trying to get insights along the way. That's what matters more than writing clean code at this point. And so you get to the point now, like, all right, cool. It's really crappy code. I would never submit this as a PR or an MR, but I'm going to commit it now because I know it works. And from there, you get to do your cleanup. You get a clean house. You already rearranged all your furniture, and now you need to go back and clean everything up. So here, what you do is you're going to make a small change that you know you want to do. Run your test. Make sure it stays green. Okay. I'll make another change. Run your test. The test stays green. Okay, great. Make another change. Oh, test is red. Oh, I better go back. I'm going to undo that. Okay, I'll make my change again. Okay, back to green. And you do this, and you continue doing it until you get to the point where you're satisfied with the quality of your code, and you're ready to submit it as an MR or a PR. Yes?
The one place where I always use test-driven development is when I'm fixing a bug. Start by writing the test.
Exactly, yeah. So
Repeat for the recording?
Yeah, I'm going to, yeah. So one thing, you want to do is, like, when you uncover a bug, try to reproduce it with a test first, and then fix the bug, and then get back to green. And so yeah, you can do it with bug fixes, but you can also do it with feature. Okay. This does have a cost. Frankly, there's no way around it. I'm not going to tell you it's like, oh, you're going to be so fast and so efficient. No. Adding tests does increase time. In fact, there were some studies that were done at Microsoft and IBM and Oracle, and in each case, they saw about a 15 to 30% increase in time of development. Now, this did range based on the developer who was doing it. There are outliers. Some people with substantially more time, especially for younger developers, newer developers. And then you have others that I got this, I have some experience, and they can crank it out in much less time. So there's a big range, but roughly when you average them all out, it's about 15 to 30%. They also saw in their studies that it did decrease defects. Doing kind of the conventional, where you write the test afterwards, I saw about 30% decrease in defects. Versus test-driven development, they saw almost 100% decrease in defects. Again, there's some range, but there are numbers to kind of back this up. If you're interested, you can look up that study at the bottom. It's very, very well done. They also found, too, that even though it might take more time, the increase in quality did actually pay for that extra. Okay. Oh, half an hour, just like that. Okay, yeah.
I'm just curious about the long term. So I saw that there was a 2009
Yep.
thing. Over the lifespan, having these automated testing, does it decrease development costs as you create
Absolutely, yeah.
enhancements?
It,
And has anybody documented that? Because that's a case you got to make to
Yeah, I
management.
didn't find any studies about that.
Yeah.
There is actually a fantastic book that talks about that called Accelerate. I wish I could remember the author's name. If you look it up, it's a very popular book about, they're advocating for continuous delivery, which is like releasing every day. But it's a really good book where they do kind of get into the weeds in terms of like how automated testing actually helps with development long term. But yeah, to your point, you're exactly right. With automated tests, you do increase the longevity of your project. You don't have to scrap it. And why do you think Drupal's been around so long? This has test coverage for a long time, right? Or those like some of those contrib modules, they have test coverage. That's why they're able to last for so long. Okay. So to kind of recap, I'm going to blaze through these slides. So first, you're trying to identify some code. I like to go through the thought process. At this point, it's just kind of instantaneous. But usually go like this. All right, I'm looking at my code. Is it my code? If it's not, I'm not going to write it right in the test. Is the code trivial? The getter and setter? Probably not going to write a test. Maybe if it has really like important business requirements in there, maybe, but probably not. I lean to not writing it. Is the code overcomplicated? I'm going to refactor it. Do I refactor it from overcomplicated to trivial? I suppose it can happen. I've never done that, but I suppose it can happen. Then you can like never write a test again. Right? Everything is so simple. Refactor everything out. So now I've refactored it. It's not overcomplicated. Again, overcomplicated, what it means is you have huge function with lots of conditions and a lot of dependencies. That's code that's overcomplicated. You should refactor it. I tried to follow the practice of, we just read Clean Code by Robert Martin. He really advocates for small functions. Yeah. When I read that, I was a little bit skeptical. When I started practicing it, I'm like, oh yeah, this is great.
Yeah.
So much easier, so much easier. And so that kind of goes along. Okay, so the code is no longer overcomplicated. Now I'm going to take a look at the dependencies. If there's one or two, okay, I'm going to consider writing a unit test. If there's, unless one of them is an external dependency, like a database, which it usually is with Drupal, you can't do much without the entity type manager in your test, to be honest. Okay, I'm going to write a kernel test. If there's 3 or more dependencies, I'm not really going to consider a unit test. I'm going to pretty much go straight to a kernel or a functional test, especially if one of those is a browser. Like I need to interact with a page of some kind. I'm going to do a functional test. And again, going back to the design, so here, I won't dwell on this, but you're going to cover your edge case and your corner cases with some kernel and unit tests, and then add some functional tests on top. Your tests always work together in kind of a harmonious way. They're never, or rarely, in isolation. And finally, last slide, as you're thinking about writing your tests, keep in mind that if you write a lot of functional tests, they're just going to become slower, though you might catch more bugs. On the flip side, with unit tests, they're going to be a lot faster, but you're going to catch fewer because of this slide here. You don't know as much in the application. And so, like I said, I took some material from this book. It was a really great inspiration. It got me started on this journey about learning automated testing. I cover some of their ideas here, but they also go into a lot more depth. So if you're really interested in learning more and kind of adopting it into your workflow as a developer, I highly recommend checking this out. It's a great resource. I think you'll really enjoy it. And that's it. Thank you very much. Record time. All right, I'll leave it open for questions. Yeah.
Josh, say I want to start doing more testing, and I have an existing project. What's your thought on how much time I should spend building tests for something the code I already have, versus focusing on writing tests for new code I have to write, or new functionality?
Yeah, I would go with writing some current code that you currently have that you know works, and find code that's directly related to the business. Because if you're looking for something that's like it's kind of a nominal value, you're not really going to be motivated to write it. But if you can write a test that covers business, that's like, look, I've offered real value. On top of that, your business code is going to be a little bit less than infrastructure code. Yeah.
So the one thing that I disagree with
Yeah.
is if you have overcomplicated code, you say just refactor it.
Mhm.
So I agree with refactor it, but I want to write a functional test first to make sure that my refactor is still giving the same behavior as the
Yeah.
original overcomplicated.
Yeah, I did touch on that a little bit. It's a little bit more like, yeah, I shouldn't say don't add test coverage, a little bit more nuance. One thing you might do is add a functional test to refactor it, but keep in mind that might not be the final state of your test. And so what I mean by that is you'll have a functional test, but then you might write some kernel or some unit tests as well to capture those edge cases. I mean, it really depends on what you're refactoring. But yes, I agree. Yeah. Maybe we didn't make it totally clear in the slides.
Josh, you mentioned early on about code or making sure your tests can survive changes to your code. Is there like an ethos to writing tests that can help you make sure that's going to happen, or is
Yeah, so what makes your test stable is that you're not tying your test directly to implementation details.
okay.
So functional tests, that's why functional tests are so stable. And they're not going to break because you're literally not testing any of your code directly, you're testing the browser.
Sure.
Where with your kernel test, you're actually testing the Drupal API.
Yeah.
And unit tests, you're testing even more, you're going even deeper. And so that's why unit tests tend to be more brittle, because they're closer to the implementation details.
Sure.
Of the code.
Thanks.
Yeah. Yeah.
So I don't know if you can address this. I've inherited some legacy code that has Python tests, Jest tests, and Cypress. And almost everybody's breaking except for Python when I do an upgrade of the stack. And I'm right now looking at Cypress seems to be moving more towards Jest, and Jest seems to be moving more towards Cypress about what they cover, front end, back end.
Okay.
And if you have any thoughts on what's going on in the test world.
I'm afraid I don't. I've been focused on the Drupal test world.
Okay.
So as far as that technology, I couldn't really give you any guidance. If you're trying to kind of rein them in, consolidate them, or
Well,
get some
it would be,
sanity.
yeah, I'm trying to figure out, does it make sense to go to one, Cypress or Jest, or I think Python.
The less you have to know, the better. All the time. Yeah.
I could provide somewhat of an answer, knowing a bit about Cypress, is that the way it's mainly used is for like the functional tests, so that
Right.
end-to-end testing.
Mhm.
So if you have Cypress tests that are breaking because your code is changing or being upgraded, to me that says the Cypress tests are brittle. They're not testing the browser, right? They're not testing the user's interaction, and so that's something to look into what your Cypress tests are covering, because they're supposed to be, my understanding is that they replicate what the user's doing in browser. And if your code, updating your code to the latest version is breaking that experience, then there's underlying problems that with
Yeah.
updating your code, which means it's
Yeah.
not serving the way
Well,
it's being used.
what I'm experiencing is Cypress has a significant upgrade
Yeah.
that requires some big changes, and so does Jest.
Oh, okay.
And so I'm looking at the stack that I've inherited that is literally 6 years old and hasn't been touched, okay? And so there's a lot of underlying things I have to clean up. But one of the things I've been trying to figure out is, what I see is that Cypress is also starting to go down the stack,
Mhm.
as well as the functional. And Jest is sort of starting to come up the stack. And I was just wondering if anybody has thoughts on, I'd love to get rid of one of them, if that, if they're gonna be doing the same thing, because keeping up with all the tools
Yeah.
is part of the problem, which is why you're just like, okay, is there a more straightforward way?
Yeah, it kind of goes back to this point here, maintainability.
Yeah,
Yeah.
This is a lot harder to run, right?
So maybe the answer is to choose either Jest, which I've never heard of before, or Cypress, but to maintain a distinction between functional and unit
And
tests.
units, this was, yeah.
Even
like-
though you're doing both of them with the same test system.
Right. Well, we also have, actually Python tests are really doing the real unit test, but then Jess is also doing it, yeah, it's,
Yeah.
it's exciting. But that's, okay,
Yeah, the more you can be divorced from the technology,
yeah.
especially if you're trying to migrate over and stuff, it probably be easier. More end-to-end tests, more functional tests.
Right.
They'll be a little more stable.
I used BHAT for another stack that I inherited.
Yeah.
So, yeah.
Yep, that's the firmly in the maintainability key right here.
But it's the tool, the testing tool, that is my challenge right now,
Yeah.
which is another twist in the whole thing, is that it's not immune, testing is not immune to the changes that other.
Exactly. Yeah, that's the other thing too I didn't really talk about is that as you're adding tests and stuff, you're going to have to go back and look at your tests and like, okay, do I need to kind of rethink my strategy here? So the tests also have some maintenance, just to improve it. Actually, we're getting time ahead. I just ran into this with the access policy module I was telling you about. No, just on a high level. This module is super configurable. You can have all sorts of kind of different scenarios. And what I ended up finding is in order to cover that, I was writing a lot of functional tests. And I was like, well, I need to practice when I preach here. So I started to break it up into more kernel and unit tests in order to kind of capture that, just whittling down my functional tests. And so, but anyway, thank you very much.
Thank you.
Don't forget to hit the button.